Hi, my name is David Goad, and welcome to my 10-minute Tech Talks. The topic of today's 10-minute Tech Talk is on the Internet of Things, also known as IoT, architecture made simple. Essentially, the purpose of this talk is to help business managers understand the sort of key questions they need to be asking themselves around the Internet of Things if they're going to invest in the Internet of Things, and what kind of technologies that they should be looking at. And it's intended to address a fundamental problem with the Internet, and that is complexity. So if you look at this diagram here, this is the IoT reference framework produced by the IoT Association of Australia. It lists all the different layers or components of a typical IoT solution. And they identify upwards of 10 different layers, from the IoT endpoint to the gateway, connectivity, connection management, intelligent enablement, application enablement, the user interface, the users, the solution providers, and the industry solutions. So IoT solutions can be very, very complex things. So the question is, how do you make sense of this? How do you simplify this down to be able to pick the right solution for you? And so that's the purpose of this video. The idea being that I'll give you 9 key questions that you can ask your technical folks and or your IoT vendors, and in so doing be able to narrow down the solution to what you really, really need, and so simplify this really, really complex thing which is called the Internet of Things. So as I said, how do you make the Internet of Things simple? Well, there's just a few key questions, and in this case 9 questions, that if you ask yourself these questions, you can simplify things down to the technology. So what's the first question? Well, the first question you need to ask yourself is this the thing that you're going to be connecting to, the device, the sensor, the actuator, the things in the Internet of Things that you're going to be connecting the Internet to, will it be mobile and will it be fixed? And when I mean not just mobile within the country, but mobile across multiple different countries. And the reason why I ask this question first is because depending on the country that you operate in, there will be a different set of standards that you will need to have your device comply to. So therefore, it is important to understand which countries and which areas, geographies in those countries that you're going to use your device. That will narrow it down considerably in terms of which technologies, which protocols, which standards that you need to use. The second question you want to ask yourself about how you're going to be using the Internet of Things is, will you be controlling things or will you be monitoring? In other words, are you just going to be pulling information in from the things that are connected, that you're connecting to the Internet, or are you actually going to control those things? For example, if you're just using a Fitbit on a person's arm and you're collecting information from that Fitbit, then you're simply monitoring. However, if, for example, you're going to be connecting up a traffic light to the Internet and you want to be able to change that traffic light, then you're controlling. The reason why you have a question is because it determines whether it's going to be a two-way communication system or a one-way communication system. And what you have to recognize is that two-way communication systems are not always better because they require more security. In some cases, it's easier to have a one-way communication system where the information is only going from the sensor, from the thing, the device in your Internet of Things, to your central system. It's a one-way transaction. If it's a two-way transaction, it requires more security and can be more of a challenge. So you really need to ask yourself the question, are you going to simply be controlling or are you going to be monitoring? The next question you need to ask yourself is, will your things, the devices that you're connecting to the Internet, will they be reasonable? And this is a very, very common problem in terms of the Internet of Things. If you're connecting everything from parking sensors to traffic lights to motion sensors to cameras, these can all, in remote locations, these can all be severely resource constrained. And it's a problem that's not common in traditional IT, because if you have a laptop or a mobile phone, they typically have ready access to power, right? They can have automatic updates. They tend to have a lot of compute and storage, and you really only expect them to be out in the field for maybe 2 to 3 years. However, if you're going to use an IoT device that's battery powered, you could expect it to be out in the field for up to 10 to 15 years, and it may not necessarily have ready access to power. So therefore, it's going to be resource constrained because you're going to design it with a low amount of compute, CPU, storage to basically reduce costs and also reduce power consumption. That means that the traditional protocols and standards that are used in the internet, like HTTP and TCP/IP, are not usable because they create too much overhead and consume too much power. So you may need to look at other types of standards and protocols such as MQTT, COAP, AMQP, and UDP, which are all standards designed for resource-constrained environments. So that's the big question: is are you going to have a resource-constrained device? Is it going to be installed somewhere where you're going to have it in situation for a long period of time with limited amount of power, and therefore it's going to have limited compute, limited storage, these kinds of things. The next question you're going to have to ask yourself is, will you have to have a constrained or unconstrained network? The challenge here comes that typically in the last sort of kilometer of internet connectivity before you hit the thing, that could be the most critical in terms of your IoT solution. Due to the physical locations, for example, the remoteness, difficult or extreme environments, for example, in a factory, networks, both wired and wireless, can become constrained and have high degrees of latency and high potential for packet loss. In other words, there's a lot of interference that goes on. These are referred to as low-powered and lossy networks. So there are new standards and tool sets that people are coming out with to support those low-powered, lossy networks. The question you're going to have to ask yourself is, will you have a resource-constrained network because of the way where you're actually putting the physical thing that you're connecting? The next question you have to ask yourself is, are you going to have a high volume of data, or are you going to have a low volume of data? Or are you going to send a sensor signal once a day, or are you actually sending telemetry, almost real time from the device or thing? And the reason why you're going to ask that question is because of this issue of just the cost of storing up in the cloud. Everyone knows in the last 5 or 10 years there's been a migration from on-premise to private cloud to now private cloud to public cloud, and people are moving a lot of their technologies to the cloud. The challenge with that is, of course, that you will be consuming bandwidth. There is a latency involved in moving things to the cloud, and cloud storage, depending on how you set it up, can be expensive. So what you're finding these days is when people in the last 5 or 10 years are moving to the cloud, now they're kind of moving backwards, and there's something what they refer to as the fog, or in some cases they call it the mist. And the reference here is the fact that the actual physical compute is actually closer to the devices consuming that compute. And so these days, a lot of people, one of the more popular technologies that have come out in the last few years is something referred to as edge devices or edge computing. And this is where the actual computing device is actually sitting closer to the devices that it needs to connect with. And it provides a seamless integration into the cloud. So it uses the cloud when it needs to, and it can compute or do storage locally when it needs to. So the question will be, if you're going to put in this new IoT solution, are you going to need some form of edge computing or fog to be able to support it due to the large amounts of data that you're generating, or due to availability issues? The sixth question you need to ask yourself is, will your devices be communicating over longer ranges or shorter ranges? So this is a diagram that I've pulled off the internet, and basically illustrates all the different types of communications technologies that are available and the trade-off between the power consumption, the bandwidth that it can support in terms of the data transmission, and the physical range, right? So there's a fundamental trade-off between bandwidth, power consumption, and range versus the cost of the actual communications technology. So for example, 3G, 4G, and 5G mobile networks, particularly 5G, which is becoming popular, and people are saying that this is going to expand the use of the Internet of Things, right, are still relatively costly. And they're costly from a power consumption perspective, not just from a usage perspective, but also a power consumption perspective. So there are a lot of other technologies that have come out, technologies and protocols and standards, which have come along to address the issue of resource-constrained devices, or those devices that require low power consumption, and those devices that are put in remote locations and have communication challenges. So a number of these technologies include things like LoRaN, Sigfox, NB-IoT, LET-M. These are all different technologies that are being used to be able to connect the things to the Internet of Things, and they're designed to operate in ranges over from 1 to 10 kilometers, and they're designed for resource-constrained devices which require low power consumption. And so that's what this diagram illustrates, is depending on the distance you want to communicate over, depending on how resource-constrained your device is and how low power you want the consumption, depending on the cost that you want to spend, that will determine which of these communication technologies that you might want to use. And then there's even other technologies that are designed for even shorter distances. For example, Bluetooth Low Energy, or BLE, Zigbee, Z-Wave. These are all technologies designed to replace Wi-Fi, which Wi-Fi in and of itself can be very expensive or consume a lot of energy. So these are low energy solutions which are designed for sub 100 meter distances to be able to provide communication. So that's the next question: what distance you're going to communicate over, and what kind of technology you're going to use. The next question, question number 7, is, do you prefer this concept of adoption versus adaption? Explain. The challenge here is that most of your IoT systems are probably going to be connected to a number of existing technologies. So there will be existing resources or technologies that you may be connecting your IoT system into. For example, if you're in a factory situation, you may already have programmable logic controllers which you're connecting into as part of the IoT. So they represent existing technologies. A lot of these exist, or another example might be actually building management systems where you might have something controlling the temperature, CO2, the ventilation. The challenge with these technologies is they're often serial in nature. They're designed to be isolated, separate, complete systems. They're not designed to connect to the internet. They often have serial analog connections depending on the age of the technology. So how do you connect them into your Internet of Things toolset? Well, you have two options. You can basically say you can do adoption, which involves using the existing connectivity but adding a gateway, so some form of gateway server that connects with the existing technology and then provides an internet or an IP connectivity to the internet. Adoption basically says that you're going to systematically replace all those devices with IP-enabled devices which connect directly to the internet and therefore provide you with a better level of connection. One is the cheaper option, so adoption is definitely cheaper than adoption. However, adoption provides you with flexibility and certainly gives you more options and is probably the longer-term solution. But a lot of organizations, because the benefits of IoT are closely tied to cost, then a lot of organizations may choose adoption in terms of their strategy. The next question you need to ask yourself is, do you have a preference for proprietary solutions? Just like, so the open source movement began in the late 1990s and has been gaining favor in IT, particularly over the last 10 years. So there are a lot of open source technologies, particularly in things like IoT and AI, that people are now using, right? And open source generally refers to the pragmatic methodology that promotes the free distribution and access to the end products and implementation. So it's open source technologies, everyone shares, everyone contributes to it and supports it, right? The challenge here is some IoT organizations prefer open source, some don't prefer open source. There are advantages and disadvantages to open source. The advantages to open source are that you're not locked into any specific vendor, you're not locked into any specific technology. You can modify that. The disadvantage with open source is that no one's supporting that specific technology or that capability. So a lot of people don't like that. A lot of people prefer a vendor managing the technology for them and being responsible for that technology and being on the hook for it. So you'll find in the IT industry that there's people who are very pro open source and people who are very anti open source. You're going to find the same in IoT. There'll be people who are very pro open source and people who are very anti open source, and you need to really understand that. So that's one of the questions: are you going to support open source or not? And then probably the last question you want to ask yourself is, where are you at in your AI IoT maturity curve? And is a depth strategy more important or better for you than a breadth strategy? Explain. This is a typical IoT, Internet of Things, and AI artificial intelligence maturity curve. I tend to talk about IoT and AI together simply because IoT provides you the data that then is used by AI to do the useful things and to come up with the useful conclusions. Most organizations go through a traditional maturity curve. So they start out being reactive, where they collect data, but they don't quite know what it is. Then they get some history, where they develop history. They just start building some reporting, generating some KPIs. Then they move that historical analysis to a real-time analysis, where they get dashboards and streaming analytics that they can see real time. Then they start applying some AI and machine learning to it and start doing some scoring and classification and making some prediction in terms of what they think is going to happen to provide advice to the people managing that process or system. Then they'll start using the AI to be prescriptive. In other words, they'll start generating recommendations, building simulations, really providing a true digital twin. And then over the course of time, once they trust or they believe in that AI capability and that automation capability, they'll go fully autonomous and allow the system to manage itself. What typically happens for most organizations is they either adopt what I refer to as a breadth strategy or depth strategy. Breadth strategy says that they bring the whole organization up to like level 1 or level 2 in terms of the data collection, the real-time information, but they don't have a high degree of automation because they find more benefits in just collecting all the information. Or what they will, or and the other strategy is a depth strategy, where they'll pick one specific process or system and they'll go very deep, not only collecting all the data, going real time, but then they'll go prescriptive and use AI across that. The decision about whether you want to go breadth versus depth really depends on your business process, your business, and the business case that you would generate out of it. For some organizations, they want to see across the whole organization, and that provides a better business case. For other organizations, there's really certain key processes that they want to automate, and so therefore they will go depth. So that's the end of my tech talk on IoT or Internet of Things architecture and the sort of 9 key questions that you need to ask yourself when coming up with an architecture that you could ask your vendors or you could ask your IT folks when they're looking, if you're looking at the IoT. If you're interested in learning more, I've actually written a book on this, which you can find up on Amazon, called Internet of Things from a director's perspective, Ask the Smart Questions. So that's the link there. If you want to ask me a question specifically, you can send me an email to david.goat@sydney.edu.au. If you'd like to connect up with me on LinkedIn, you can use that QR code and that will bring you to my profile on LinkedIn. You can connect up with me that way. Anyways, I hope you found this video interesting, and thanks, and enjoy your experimentation in the space of IoT. Thank you.